Hello students, welcome to the chapter Inverse Trigonometric Functions. This is lecture number 7. In this video, let us see some more properties of inverse trigonometric functions and problems. This property will help us to simplifying the complex expressions. The property that we are going to see now, it will help us to see to solve some problems which are complex. Those are tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus xy, where xy is less than 1, product x and y less than 1. It is a condition on x and y. Not to remember, no need to remember students, just remember if it possible, otherwise not a issue. Tan inverse x minus tan inverse y is equal to same pattern, but tan inverse of x minus y upon 1 plus xy, where xy is greater than minus 1. Third one, sin inverse x plus or minus sin inverse y is equal to sin inverse of, look at the RHS, x into root of 1 minus y square plus or minus y into root of 1 minus x square. Here plus comes, then in the RHS plus will be there. Here minus comes, in the RHS minus will be there. And the conditions on x and y you can remember. Fourth one, cos inverse x plus or minus cos inverse y is equal to cos inverse of xy minus plus. Take care about the signs. When plus in the LHS, minus should be in the RHS. When minus in the LHS, plus should be in the RHS. So cos inverse of xy minus or plus root of 1 minus x square into root of 1 minus y square. The conditions on x and y are here. Dear students, again I tell you, we need not remember all the conditions. Okay, just remember the formulas. Let us prove the first one. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus x into y, where xy is less than 1. To prove this one, let me take tan inverse x as theta, that you can see. This tan inverse x I am taking as theta. Then tan inverse y as pi, to note it. Then x is equal to tan theta. Then only y is equal to tan pi. So these are the values of x and y. So after that, now consider a formula in trigonometry, tan of theta plus pi, that will be tan theta plus tan pi upon 1 minus tan theta into tan pi. Now replace the value of tan theta, that is x, then tan pi, that is y, in this RHS, so that you can see x plus y upon 1 minus x into y. Dear students, apply tan inverse on both the sides, students. This is actually tan inverse on both the side, so that tan inverse of tan theta plus pi is equal to tan inverse of x plus y upon 1 minus xy. Either you remember like apply tan inverse on both sides, or just you can take tan to the right side, that is also possible. So tan inverse and tan get removed. In the next step, theta plus pi is equal to tan inverse of x plus y upon 1 minus xy. Now remember, tan inverse x is theta, tan inverse y is pi. So replace theta and pi value as tan inverse x plus tan inverse y, that is equal to tan inverse of x plus y upon 1 minus x into y. So you can remember this, taking tan inverse x equal to theta, tan inverse y as pi, using tan of theta plus pi formula, and you will get the required proof. Let me take one more. Tan inverse x minus tan inverse y is equal to tan inverse of x minus y upon 1 plus x into y, where xy is greater than minus 1. Dear students, for this, let me take tan inverse x as theta, like previous, tan inverse y as pi, so that x is equal to tan theta and y is equal to tan pi. But here I am taking a formula that tan of theta pi, but here I am taking a formula tan of theta minus pi, that will be tan theta minus tan pi upon 1 plus tan theta into tan pi. Replace tan theta and tan pi value, that is x minus y upon 1 plus x into y. Here also apply tan inverse on both the side, so that you are going to get tan inverse of tan theta minus pi, tan inverse of tan theta minus pi. In the right hand side, tan inverse of x minus y upon 1 plus x into y. So that in the LHS, tan inverse and tan gets cancelled. Theta minus pi is equal to tan inverse of x minus y upon 1 plus x into y. So replace theta and pi value, that is tan inverse x and tan inverse y. So that will be tan inverse x minus tan inverse y is equal to tan inverse of x minus y upon 1 plus x into y. These are the two theorems will help us to solve complex inverse trigonometric problems. Based on these, let us have questions. Number 1, prove that tan inverse 1 by 2 plus tan inverse 2 by 11 is equal to tan inverse of 3 by 4. The proof of this one, let us consider the LHS, that is tan inverse 1 by 2 plus tan inverse 2 by 11. Dear students, remember this formula, tan inverse x plus tan inverse y is tan inverse of x plus y upon 1 minus x into y. So that will be, here x value is 1 by 2, y value is 2 by 11. Using this one, here I am going to write x value 1 by 2, y value 2 by 11. That the procedure will be now. Concentrate. So tan inverse of x, that is 1 by 2 plus y 2 by 11 divided by 1 minus x into y, that is 1 by 2 into 2 by 11. So after applying this formula, solve this expression, students. This is very important, solving the expression. So tan inverse of, dear students, 1 by 2, I will take the simplification separately. Only this bracket I will simplify. 1 by 2 plus 2 by 11. LCM of 2 and 11 is 22. If you cross multiply, 11 into 1, here 2 into 2. So 11 plus 4 divided by 1 minus 1 into, otherwise 1 minus 1 into 2 is 2 upon 22. So this will be tan inverse of 11 plus 4, 15 upon 22. 22 into 1, 22 minus 2, that will be 20 upon 22. So 22 and 22 gets cancelled. You left with 15 by 20. Directly we are giving the simplification that you can see there. So after tan inverse of 15 by 20, you can cut it by 5 3s are 5 4s are. So tan inverse of 3 by 4 is the required and it is the RHS. Hence we proved tan inverse 1 by 2 plus tan inverse 2 by 11 is equal to tan inverse 3 by 4 using tan inverse x plus tan inverse y formula. Similar to this, let us consider one more. Prove that tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Let us consider the left hand side, that is LHS. So that will be tan inverse 2 by 11 plus tan inverse 7 by 24. Using a formula again, tan inverse x plus tan inverse y. So that will be tan inverse of x 2 by 11 plus y 7 by 24 upon 1 minus x into y, that is 2 by 11 into 7 by 24. Solve this expression like previous example, taking the LCM and cancelling. Then you are going to get tan inverse of, see the simplification, cross multiplication and the LCM 264. 11 and 24 LCM is 264 divided by 264 minus 14 divided by 264. Simplification as we discussed in the question number 1. So that you are going to have tan inverse of, the numerator will be 125. Here 264 and 264 gets cancelled. So 48 plus 77 is 125. 264 minus 14 is 250. Then 125 upon 250, 125 ones are 125 twos are. Therefore tan inverse of 1 by 2 we are going to get and it is your RHS. Hence we proved LHS is equal to RHS. Like that, question number 3. All these are important for 2 or 3 more questions. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse of 31 upon 17. Here you should concentrate on this much. 2 times of tan inverse 1 by 2 is there, that we will simplify like this. Unlike the previous 2 problems, here we have the first term on LHS as a 2 tan inverse 1 by 2, that I told you focus on this much. Solve that. So let's first consider the term 2 tan inverse 1 by 2 and simplify it. 2 tan inverse 1 by 2 can be written 2 times, like tan inverse 1 by 2 plus tan inverse 1 by 2. Again use the property tan inverse x plus tan inverse y. So here x values are 1 by 2 and the same 1 by 2. So that tan inverse of 1 by 2 plus 1 by 2 divided by 1 minus x into y, that is 1 by 2 into 1 by 2. Simplify this expression. So that tan inverse of 1 by 2 plus 1 by 2 is 1 divided by 1 minus 1 by 4. then tan inverse of, in the denominator 3 by 4, then take this 4 to the numerator, so that you are going to get tan inverse of 4 by 3. So this is the value of the first term, that is 2 tan inverse 1 by 2 is equal to tan inverse 4 by 3. So keep it safe, 2 tan inverse 1 by 2 as tan inverse 4 by 3. Then take the second term of the LHS, or directly you can consider LHS. 2 tan inverse 1 by 2 value is tan inverse 4 by 3 plus tan inverse 1 by 7 as it is. Again use tan inverse x plus tan inverse y here. So that tan inverse of x 4 by 3 plus y 1 by 7 divided by 1 minus x into y, that is 4 by 3 into 1 by 7. So if you simplify that expression, look at the screen, cross multiplication, 7 into 4 28, 3 into 1 3, divided by LCM of 3 and 7 21, divided by 1 minus 4 upon 21 will be simplification, 21 upon the simplification of the denominator is 21 minus 4 divided by 21 and 21 gets cancelled, so that tan inverse of 28 plus this 21 and 21 gets cancelled, 28 plus 3 is 31, 21 minus 4 is 17, so that 31 upon 17 will be the final, and this is our required RHS. Hence we proved LHS is equal to RHS. Let us have some more questions, calling that as question number 1, using the properties. Cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse of 33 upon 65. Dear students, this is also very important for 3 mark. Concentrate. Here which formula I am going to apply directly? Cos inverse x plus cos inverse y formula I apply, that I have given you in the previous discussion, cos inverse x plus cos inverse y formula. So let me take the LHS first. Cos inverse 4 by 5 plus cos inverse 12 by 13, using a formula cos inverse x plus cos inverse y is equal to cos inverse of xy minus root of 1 minus x square into root of 1 minus y square. Here x value is 4 by 5, y value is 12 by 13. Substituting these directly in the formula, so that cos inverse of x into y 4 by 5 into 12 by 13 minus root of 1 minus x square, that is 1 minus 4 by 5 the whole square, 4 by 5 the whole square directly 16 by 25 into root of 1 minus y square 1 minus 12 by 13 the whole square, that is 144 upon 169. Dear students, hope you remember how to simplify such expressions. Simplify that directly. So cos inverse of 4 into 12 upon 5 into 13 is directly 48 upon 65 minus this root and all simplification will be 3 upon 5. If you go for simplification, you will get 3 by 5 into first root you will be getting 3 by 5, then second root will be 5 by 13 you will get. The second root simplification is 5 by 13. After all the simplification, go for this bracket simplification, 48 upon 65 minus 3 into 5 15 upon 65, so that you are going to get cos inverse of 33 upon 65. Finally, after all the simplification, cos inverse of 33 upon 65 you will get, and that is our required RHS. Hence that is our required RHS. Hence we proved LHS is equal to RHS. Let me take question number 2 on the same. Prove that cos inverse 12 by 13 plus sin inverse 3 by 5 is equal to sin inverse of 56 upon 65. Dear students, observe cos inverse, sin inverse, sin inverse. If you convert cos inverse into sin inverse, then you can easily apply a formula here, that is sin inverse x plus sin inverse y. Directly you have a formula, so that it will be simple to simplify. Solution. Here on the LHS, let's try to express both the terms in terms of sin inverse. As I told you, let us consider then cos inverse of 12 by 13 separately. So that cos inverse of 12 by 13, take it as theta. So cos theta will be 12 by 13. Draw one right angle triangle here. So that cos definition is adjacent divided by hypotenuse. This is adjacent, this is hypotenuse, this is opposite. So adjacent upon hypotenuse. Then what will be opposite side using Pythagoras theorem? Pythagoras theorem, you angle triangle. This is adjacent side, this is hypotenuse, this is opposite side. Using Pythagoras theorem, what Pythagoras theorem said? Hypotenuse square is equal to opposite square plus adjacent square. Hypotenuse square means 13 square, opposite square don't know, keep it as it is, adjacent square that is 12 square, 13 square is 169. Opposites square 144. So opposites square can be written 169 minus 144. Using Pythagoras theorem I am solving. Opposite square is 169 minus 144 is 25. Just opposite side, not square. Root of 25 will be 5. So what is opposite side value? That is 5. So using Pythagoras theorem you will get the opposite side as 5. So after that you can write sin theta. Sin theta definition, opposite divided by hypotenuse, that is 5 by 13. So sin inverse of 5 by 13 is theta. So here you have taken cos inverse 12 by 13 and it is also equal to sin inverse of 5 by 13. In terms of sin inverse you expressed. After that let us consider the LHS, that is cos inverse of 12 by 13 plus sin inverse of 3 by 5. The expressed value of cos inverse you will write now, that is sin inverse of 5 by 13 plus sin inverse 3 by 5. So directly you can see the sin inverse x plus sin inverse y formula here. So using sin inverse x plus sin inverse y is equal to sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square. Here the value of x is 5 by 13, y value is 3 by 5. So substitute x and y value in the formula. So that LHS will be now sin inverse of x is 5 by 13, root of 1 minus y square, that is 1 minus 3 by 5 the whole square, 9 by 25, plus y means 3 by 5, root of 1 minus x square, that is 1 minus 5 by 13 the whole square, that is 1 minus 25 upon 169. Solving this expression, sin inverse of the first simplification will be 4 by 13 plus second simplification will be 36 upon 65. Taking LCM and cross multiplying, you are going to get sin inverse of 56 upon 65. This is going to be the RHS. Hence, this is going to be the RHS. Hence, we proved the LHS is equal to RHS. These are the problems on the properties, conversion of one inverse into another inverse. Thank you, students. These are the few discussion that I have taken in this video. Let us see some more discussion in the next class.